Hi friend, myself Jitendra Kumar. I am taking electrical machine design for the electrical engineering student of 7th semester. As per the previous lectures, we will continue about the electrical engineering materials. Under this, we are just in this lecture we are discussing all the magnetic materials and their specifications. The magnetic materials having some properties which are the most important for identifying the material which we have to use for different types of operation of parts of the machine. Under this, one property is the saturation density of the material, corrosive force, permeability, specific iron loss, density, retentivity, retaining magnetic property with them, ease of machinability, how easily it can be machinable in nature. So these are the properties which will associated with this one. Next is the insulating material. There will some insulating material properties are there. High dielectric strength, sustained at elevated temperature, high resistivity or specific resistance, good thermal conductivity, high degree of thermal stability, low dielectric stresses, good mechanical properties, and ability to withstand moisture, chemical attack, and heat, etc. That will be the property of the insulating material. While we have to just to decide that which type of material we are using for the insulation purposes. Next will be the classifications of the material or the insulation as per their temperature. So there will be the seven categories of the material which will be identified about the on the basis of their temperature limit. There is a class Y material having a temperature limit of 90 degrees Celsius, class A type 105 degrees Celsius, class E type 120 degrees Celsius, class B type 130 degrees Celsius, class F type 155 degrees Celsius, class H type 180 degrees Celsius, and the class C type less than 180, oh sorry, more than 180 degrees Celsius temperature will be the limit of the component. Now there is a class Y type material. This insulation consists of materials or combination of materials such as cotton, silk, paper without impregnation. Other materials or combination of materials can be included in this class if by experience or accepted test they can be shown to be capable of operating at class Y temperature. Example of this one is the cotton, silk, paper, glucose, wood, etc. Neither impregnated nor impregnated oil. Materials of class Y are unsuitable for electrical machines and apparatus as they deteriorate rapidly and are extremely hygroscopic in nature. Next will be the class A type material. The insulation consists of materials or combination of materials such as cotton, silk, paper when suitably impregnated or coated when imprisoned in a dielectric material. Next will be the liquids such as oil. Other materials or combination of materials can be included in this class A. If by experience or accepted test they can be done shown to be capable of operating at class A temperature. Example, materials of class A impregnated with natural resins, cellulose esters, insulating coils, etc. Also included in this class are laminated wood and the varnished paper. Now the class E type material. This insulation consists of materials or combination of materials which by experience or accepted test they can be shown to be capable of operating at class E temperature. Material possessing a degree of thermal stability, allowing them to be operated at a temperature of 150 degrees Celsius higher than class A type material. Example of this type of class E material is the synthetic resin enamels, cotton and paper laminates with formaldehyde, hydrogen bonding, formaldehyde, bonding, etc. Naturally, the class B type insulation. This insulation consists of materials or combination of materials such as mica, glass, fiber, asbestos, etc. with suitable bonding substances. Other materials or combination of materials not necessarily organic may be included in this class if by experience or accepted test they can be shown to be capable of operating at class B test temperature. Example of this type of machine is the mica, glass fiber, asbestos with suitable bonding substances. Such mica built up mica, glass fiber and the asbestos laminates. Actually, with the class F-type material, this insulation consists of material or combination of materials such as mica, glass fiber, asbestos, etc., with suitable bonding substances as well as other materials or combination of materials, not necessarily inorganic, which by experience or accepted test they can be shown to be capable of operation at class F-type temperature. Material possessing a high degree of thermal stability allows them to be operated at a temperature 25 degrees Celsius higher than class B type material. Example of this one is the materials of class B with bonding materials of higher thermal stability are the example of the class F type. Next category of the material is the class H type. This insulation consists of materials such as silicon, elastomer, and combinations of materials such as mica, fiberglass, asbestos, etc., with suitable bonding substances such as appropriate silicon resin. Other materials or combination of material may be included in this class if by experience or accepted test they can be shown to be capable of operating in class H type temperatures. Actually, the examples of the class H type materials is glass fiber and asbestos materials and build up saturate with silicon resins. Next one is the class C types material. This insulation consists of material whose combination of materials such as mica, porcelain, glass, and quartz with or without an inorganic binder. Other other materials or combinations of materials may be included in this paper. If by experience or accepted tests they can be shown to be capable of operation at temperatures above the class H limit. Native specific materials or combination of materials in this class will have a temperature limit which are independent or dependent upon their physical, chemical, and electrical properties. Now their examples are the mica, ceramic, glass studs without binders or with silicon resins of higher capability, higher thermal stability of the machine. Now this is the ending of the different types of material which we are discussing over to control the properties of the materials or the insulation which will be provided over the machine is the important parameter which we have already covered under this heading. Thank you.